Hello, back with another lab intro video for Physics 1410, this time for Experiment 8. Experiment 8 is pretty similar to, I think it was Experiment 6, where you were dealing with the water tank and sound and all that stuff. This is focusing more on interference, but there is a lot of overlap between them. So there are a couple of questions at the outset. How do you describe interference? What are constructive and destructive interference? What's an interference pattern? Pretty kind of straightforward description. It doesn't need to be super in-depth. So the exercise, unfortunately, we've got another one of the Java ones up this week. I've already got this open in a tab so that I can download it and run it. But this one is one of the Java applets that they haven't quite updated yet. So I'm just going to go ahead and save this and open it after I click to download it. Wait for it to finish. All right, load this guy up. I'm not going to enable the audio, but it does ask you to do this, preferably with headphones, but however you want to deal with it. If you do enable the audio, well, you have to enable the audio to answer some of the questions. So when you enable the audio, the first things that it's going to ask you to do is to, on the single source tab, which is where it opens, give me the effect when you change the frequency. And it's not discussing changing the frequency with respect to what you see, but what you hear. Does the pitch change? Does it go up or down? Does it get louder, softer? Those types of qualifiers. And then also it asks you to change the amplitude. So again, these are not referring to what you see, but what you hear with the audio enabled. Again, I'm not enabling this because I'm not sure how that would sound in the video if I actually turned it on. It might overwhelm anything that I'm going to say. So frequency and amplitude, how do those change what you hear? Then a blank page for some reason. And then it's asking you, when can you still hear the tone when you change the frequency on the slider? So it first asks you to set this to 100 hertz or as close to 100 hertz as you can get it, because it's kind of hard to set it exactly where you want it. So I'll just get it like 101. And then you're going to play with the amplitude and figure out where is the last place you can hear it. And then you're going to change it to 1,000 hertz and do the same thing. So these are, they will click to one of the marks, which means 0 is nothing. 100% here is as loud as the simulation will make it. And so each of the marks is 10%. And it just wants you to know where you have this on here. Where's the last place on the amplitude slider where you can still hear the sound. When I've done this before, I typically can hear it all the way before it cuts off. So I get it down to the last mark with both. But because this is not like a real fine control, that doesn't, may not give you the idea about whether you hear higher frequency or lower frequency sounds better. If you have them at the same mark, just kind of gauge which one sounds louder to you and answer that to the best of your ability. After that, you're going to move to the Measure tab on here and use the tools that are present to try to figure out what the speed of sound is. Now, there are two ways that you could go about this. You did do something like this in, like I said, I think it was experiment 6 where we did the wave thing. where you had the waves moving off the screen and you timed them moving off the screen so that you could measure the frequency of the wave. But I'm going to go ahead and say, don't even worry about trying to measure with the time tool, is my suggestion. You have the frequency up here. So remember, the speed of sound is equal to wavelength times frequency. So if you can set the frequency to whatever you want. You can leave it at 500 or you can change it to something else. And then you can measure the wavelength. Remember, you want the distance between 2 points that are in phase with one another. These tools here can help you because you can kind of set this somewhere and then maybe pause it and set this where you think the middle of the crest is, say. That's kind of a judgment call. And then you could do the same with this other blue line. Once you actually grab it, it's hard to do with the, so you could set that in the middle or at least in the same point, and then use your ruler to measure the actual wavelength. That's one way you could do it. Any way that you do this, you're going to need the wavelength somehow. So you're going to have to measure that. If you use the frequency as given, then you already have wavelength plus frequency will let you estimate the speed of sound. That's one way. So the other way is to actually use the timer here to try to figure out the frequency, but that seems like overly complicated. But don't let that dissuade you if that's what you want to do. So part C is dealing with the two source tab. So we'll go to the two source. And so what you'll see visually, again, I'm not enabling the audio, but you should do that because some of the questions are specifically asking where you hear sound the loudest and where you hear it the softest. So what we're interested in is not these regions right in front of the virtual loudspeakers. Down here, there's no interference between the two sounds, so we don't want to discuss what's happening there. We're only interested in this region where the waves actually cross over one another. So the first question is to describe the pattern you see on the screen. Like I said, when we did the interference pattern before, you're totally free to just kind of print screen this and throw it in the document for simplicity's sake. But you could also kind of try to describe what you're seeing in this region. Again, we don't care about up here, we don't care about down here, we just care about in this region there. So with the listener mode on, it says headphones because we used to do this in a computer lab, and you wouldn't want to disturb everyone if you were on that part. So what it's going to ask you to do is once you enable the audio, you're going to take this guy and you're going to move him around inside the region where the waves overlap. And you want to find the spots where it sounds quietest. Clearly, it's going to be quieter out here further away from the speakers than it is up here. It's talking about if you were moving up and down more so than in and out. So there will be certain spots which you can kind of see visually here. There's this kind of pretty distinct line here, which is a nodal line in the interference pattern, a line of destructive interference. So if I were to set this guy on that line, it would be really, really quiet, almost completely deadened out. The brighter and darker regions are where the sound is most intense. So if I set him kind of right here, that would be a region of constructive interference where the sound would be louder. So it's asking you to basically find a spot where it's quiet and describe what's going on, find a spot where it's loud and find what's going on, not moving in and out, because moving in and out, naturally it gets quiet because you're further from the source here. So that is less sound, more sound. What do you think is happening there? And then it asks you to change the pattern, and there is another blank sheet here in the Google Sheets version I uploaded. So how does the pattern change when you move the speakers closer together or further apart? So you can move the top one up or down. So when you move them closer together, it's asking, you can actually overlap them almost completely, but we want some sort of overlap. So there should be some separation between the centers. You can overlap them a little bit like this, where these are separate, but you just do want to see what happens when you move them closer together versus further apart. So describe not only what happens in the pattern itself, and remember it takes a couple of seconds to update because these waves propagate out, not only what you see in the pattern itself, in terms of how dark and bright it is, but how much overlap there is, and all those kind of factors should appear in your description. Or you could take a couple of screenshots again and compare them that way. And then the last one is the varying air pressure tab. Oops, where'd I go? I lost my pointer for a sec. Varying air pressure tab. So coming back here, listen with varying air pressure. You're going to, again, enable the audio. You want to stay on the listener mode, not the speaker mode. And the first question asks you what happens to the amplitude. Does it get louder or softer? Does the pitch change? Those types of things. You're keeping the frequency constant here. So you would mess with this and describe what you hear. It should be familiar from earlier parts in the lab. And then you're going to hit this remove from air box. And what's happening is a virtual vacuum is being created inside the box where the speaker is. And you're going to be describing what you hear happen as basically the air gets pumped out of this chamber. And it should be pretty obvious what will happen after you get all the way down to 0, which is where all the air has been removed from the chamber, because sound is a pressure wave that needs a medium, and if there's no air in here, there is no medium. So what happens as the air is removed, and then describe what is happening as a result of that, which I kind of already gave you a hint on with what I just said. And after you're done with that, go ahead and upload it in Canvas, just like you did for Lab 6 and 7. And that'll be it. This one is very short in terms of what you're doing, and it's very qualitative other than the find the speed of sound part. You probably should be able to knock it out in pretty much no time flat. And just like the week before, or this week when we did the wave game Fourier analysis one, this is probably a 15 to 30 minute lab to finish once you get started. So it's pretty straightforward. And with that, that's it. So I'll have the video for introducing experiment 9 up next week, on the Monday after next probably. And you can go ahead and get started on this one whenever you want. All right, have a good day.